State the coordinate of the intersection of the terminal arm and the unit circle. So remember how we draw the terminal arm? Then we have the unit circle, and then there's a coordinate that happens at, right? The unit circle itself has unlimited coordinates, correct? Like if I asked you for the coordinate at 21 degrees on the unit circle, you could get it for me. What would it be? Haven't figured out. For 21 degrees, what would we punch into our calculators? Unit circle is what? What then what? Yeah. Opposite. Yeah, so we'd have to do cos 21 to get our x, sine 21 degrees to get our y. Remember? Calgary Stampede, alphabetical order. We agree? So, you would go cos 21 degrees, sine 21 degrees to get the coordinate. Yeah. Couldn't ask for it in exact values. I would have to ask for it in rounded decimals, yes? But I can ask for exact values of anything with a 30, 45, 60, or 90 degree reference angle. So on your unit circle, you have answers to every 30, 45, 60, 90 degree reference angle, correct? And I can ask for something that's outside of 0 to 360 as long as it's coterminal with those. Yeah? Because it'll land on them. All right. So here we have pi over 2. What's the coordinate at pi over 2? Well, it would be cos of pi over 2, sine of pi over 2, technically, yes? We're going to write this down so we remind ourselves that that's actually what it is. But what is the coordinate at pi over 2, which is 90 degrees, which is on your unit circle, which is why I told you to have that as a bestie? 0 and 1, which makes sense because it's over nothing, up 1, because the unit circle has a radius of 1, correct? Okay, negative 3 pi. We could go cos of negative 3 pi, sine of negative 3 pi. What would our calculator have to be in? Radians. So try that out. You go to push the cos button, you slap your hand and say, what mode do I need to be in? So what do you get? Negative 1 and 0. Now let's prove it by actually finding the coterminal. So negative 3 pi, if I want, I can go pi, 2 pi, 3 pi, and it would land here, correct? Which is on negative pi, is it not? So it would have the same answer. The other way we could do it is actually just literally finding the coterminal. So we go negative 3 pi plus 2 pi is what? Negative 1 pi. And I want to keep going because I want to get on the unit circle. Negative 1 pi plus 2 pi is pi. And then I could get the coordinate at pi, correct? Because it would be the same answer. So go to pi and look at your coordinate on your unit circle. It's negative 1, 0. Yes? What about negative pi? It would be negative 1, 0, right? Negative 3 pi, negative 1, 0. Positive 3 pi would be negative 1, 0. Because they would all land on that same spot. They're coterminal with each other, right? And we're getting that terminating coordinate. Okay, 7 pi over 2. 7 pi over 2. If I subtract 2 off of it, 2 pi off of it, what am I going to get? What's 7 pi over 2 minus 2? Yeah. 7 pi over 2 minus 2? What's 7 pi over 2 minus 2? Yeah. 3 pi over 2. And 3 pi over 2 is on our unit circle, correct? It's 270. So at 270, what's my coordinate? 0, negative 1. Now, do I just send it or do I check it? I check it. I go cos of 7 pi over 2 into my calculator, comma, sine of 7 pi over 2. Make sure I'm in radian mode. And I should get 0 and negative 1. Yes? Every time. Make sure you're in radian mode. Are you getting 0 and then -1? Yeah, so, yeah. So if you get anything e to the negative anything, like at the back of your number, 7 times 10 to the negative 13, or maybe 7 times e to the negative 13, that's 0. That's 0 decimal, a whole bunch of zeros, 7, right? So watch yourself, it sometimes does that. Okay. 720 degrees isn't on my unit circle, but I could subtract 360 to get a coterminal for it. But 720 minus 360? 360. What's the coordinate at 360? Do we just send it or check it? Check it. Cos of 720 degrees, sine of 720 degrees. What mode do we need to be in this time? Degree mode. So if you're still in radians, it's not going to come out correct. And here it reminds us the principal angle is the smallest positive angle between 0 and 360 degrees, or 0 and 2 pi. Okay? Okay, the point at 60, what is it? That one's a nice one. It's right on your unit circle. What's the coordinate at 60? 1/2 and root 3 over 2. Remember, we can check it. We can go cos of 60 degrees, comma sine of 60 degrees. Make sure we're in degree mode. I'm making you cos and sine, so I'm drilling into your head that the unit circle literally gives you cos and sine. Cos and sine, cos and sine. So when they give you a test question that asks you for the coordinate on the unit circle at 43 degrees, you don't tell me there isn't one. There is. You could go cos of 43 degrees, sine of 43 degrees, and round, right? It just won't be an exact value because it's just not on one of the exact value dots. But it still exists on that unit circle. Okay. Try them out. Go. 7 pi over 6 is on your unit circle. It's 210 degrees. What is the coordinate? What should be? Negative root 3 over 2 and negative 1 over 2. And we could check it by going cos of 7 pi over 6, comma sine of 7 pi over 6. Okay, 240. What is the coordinate on the unit circle? Negative 1 over 2 and negative 3 over 2. They're both negative because they're in quadrant 3. And we can check it by going cos of 240 degrees. So it's Calgary Stampede, sine of 240 degrees. 120 is in quadrant 2, so I know I'm going to have a negative x and a positive y. What is the coordinate? That. So it's cos of 120 degrees. So these ones are easier because they're directly right on the unit circle. Between 0 and 360, the principal angles are 0 and 2 pi. This one here, if you want, which a few of you will do, you can add 2 pi's till it lands on it, right? Or you can convert it to degrees and then people draw it that way. It doesn't really matter to me. If you convert it to degrees, what would we do if we did go that route? What do we multiply by? Just reminding what conversions. 180 over pi. Why is it 180 over pi? What does 180 should it have on it? A little degree symbol, correct? And then 5 times 180 divided by 3 is negative 300. If I add 360 to that, degrees, sorry, I get, that's a degree symbol, you never know, you get 60. Or you could literally just draw that, right? So if we have negative 300, it goes like this, boom, lands here, yes? But I would write negative 5 pi over 6. And by 6, I mean 3, because that's on 6. Okay? What is the coordinate here? What do you get? 1 over 2 and root 3 over 2. So there's many ways you can get to that spot, correct? You could convert it to degrees, then add 360. You could just draw negative 300. You could add 2 pi to it and then get it to be pi over 6, or pi over 3, sorry, and then draw it here, right? Like there's many ways to get to that same spot. Do you know what I'm saying? And we can check it by going cos of negative 5 pi over 3 sine negative 5 pi over 3 as a coordinate. Okay, 19 pi over 6. If I go 19 pi over 6 and I subtract 2 pi from it, that's the same as saying 12 pi over 6. So I get 7 pi over 6, which is the exact same answer as this one. Right? Lands on the exact same arm. We agree? So the coordinate would be negative root 3 over 2.5. And then negative 3 pi, we've already talked about it, was negative 1, 0. That's negative 1, 0. So it's just pulling coordinates off your unit circle. Really all I'm drilling in your heads is it gives you the cos ratio of that angle and the sine ratio of that angle. Yes? And anything that terminates on that same arm, whether it's 3, 4, 5 rotations clockwise or 5 rotations counterclockwise, still ends up with that same coordinate. Does that make sense? That's what I'm trying to get you guys to understand, right? Same coordinate, same spot. Terminating arm on the unit circle. Okay. Now, side note, put pencils down. In the old curriculum, we used to talk about determining the equation of a circle. You don't really care about that, but we're just going to pay attention for just a second here so you can see why the equation of the unit circle is what it is. The equation of a circle is x minus h squared plus y minus k squared equals r squared. This doesn't matter to you. I'm just proving it to you why when I say the unit circle formula is what it is, you understand why. Now, h and k is the center of the circle. So this would be h, whoopsies, k, and that's the center. And then r, what do you expect that probably is? Radius. Where is our unit circle centered around? 0, 0, correct? And what's our radius? It's 1. So it's our h and our k. We agree? So I plug it into this formula, I'm going to get x minus 0 squared plus y minus 0 squared equals 1 squared, which is x squared plus y squared equals 1. Do we agree? That is the equation of the unit circle, because when you fill it in, that's what you get. That's what we need to know, just that piece. So going back, picking up a pencil, we're going to go back down to here. It says determine the value of theta in standard position given the coordinate, the point at which the terminal arm intersects. So we're going to have to now give this the theta, but why is this a point on the unit circle? How do we know that? Well, we could prove it by going x squared plus y squared equals 1. And if I go negative 1 squared plus 0 squared, 1 equals 1, that is a coordinate on the unit circle. Yes? Because if I plug in an x and a y, it should equal 1. Do we agree? So these coordinates, when I plug them all in, will get me a coordinate on the unit circle, which it does tell me. The domain is given in radians, so you must give it the answer in radians. It has to be in standard position between 0 and 2 pi. So even though you like degrees, that's lovely, your answer has to be in radians. And on the test, I will always give a restricted domain in radians at some point, and people will give me answers in degrees, which is going to not get you full marks. Okay? All right. So negative 1, 0. Look on your unit circle. Where would that be located? Remember, your unit circle is on a Cartesian plane. So I'm going to negative 1, 0. What is that? Pi. Root 3 over 2, 1/2. What quadrant am I going to be in? They're both positive. First quadrant. What does that go with? Pi over 6. Now these ones people won't notice, but negative 1 over root 2 is actually the same as root 2 over 2. It's just the unrationalized version. So if I go like this, everyone's paying attention, pencils down. In grade 11, you guys were taught to rationalize your denominator, which means get rid of the radical. When it was a monomial, you just multiplied by it. When you do the bottom, you have to do the top. You just can't randomly multiply bottom. So this would get me negative 1 times root 2, which is negative root 2. And then root 2 times root 2 is root 4. which is 2. So whenever you multiply two radicals that are the same together, you get just the number because you get that squared underneath, right? You would technically get root 2 squared, and then this cancels that. That's why you get 2 every single time, right? All right. So this is just negative root 2 over 2 and root 2 over 2 technically off your unit circle. Has to be in quadrant 2 because it's a negative x positive y. What does that correlate with? 3 pi over 4. And then negative a half and negative root 3 over 2 is quadrant 3 because it's the only place where x and y are both negative. And it correlates with? Yep. 4 pi over 3. Okay, then we're going to flip over, which is the new booklet, technically, if you have your booklet separately. We're on page 5, which is the page of the new booklet. Okay, this is what I always do on a test. If it says, determine the missing y-coordinate of each point on the unit circle, I will always box, highlight, and then I'll say, oh, okay, that means I can use x squared plus y squared equals 1. Because if it's on the unit circle, that is the equation of the unit circle, I can use it. Yes? So whenever I see on the unit circle, I always write an arrow and say x squared plus y squared equals 1. Because people will sit at this question and be like, I don't know what I'm supposed to do. But if they remember the on the unit circle, x squared plus y squared equals 1, it's a really easy question. Because they're giving us one unknown. Why is there an extra bracket? Pretend that's not there. Okay, so we have an x and we have a y. We agree? Our formula has an x and a y, so if I need to solve for y, I just need x, which I do have. So let's plug it in. So we're going to get negative 4/5 squared plus y squared equals 1. Negative 4 squared over 5 squared is 16 over 25 plus y squared equals 1. Subtract it over. So I'm going to get y squared equals 1 minus 16 over 25. Now in order to do fractions, I need common denominators. So I can turn a 1 into what over 25? 25 over 25 is just 1, right? When you divide itself. So this could change to a 25, technically over 25. So I get y squared equals 9 over 25. And then when I physically do this with my hand, what do I have to remember to do? Plus minus every time. Which is why they have to tell us the quadrant. Y equals plus or minus, and then these are both perfect squares. So in grade 10 you were taught you can split a radical up, but we don't have to if they're both perfect squares. Square root of 9 is 3, square root of 25 is 5. Now if they don't give me the quadrant, the two coordinates I could have would be negative 4/5 and 3 over 5, or negative 4/5 and negative 3 over 5. I would get two coordinates. We agree? Because we found two y's. However, this one says quadrant 2. So is it the first coordinate or the second coordinate? First, because the second one falls into quadrant what? 3. Make sense? All right. We're going to bring back a little bit of grade 10 again. So for B, we have x and y. We have x, we need y. So we're going to go 3 over 10 squared plus y squared equals 1. Square both of them, we get 9 over 100. Plus y squared equals 1. Subtract the 9 over 100. What can I turn the 1 into? 100 over 100, right? So I'm going to get y squared equals 91 over 100. and then square root. When I do this, I get plus or minus. Now guys, we're going back to grade 10. You were taught something in grade 10 and you didn't even know why you were taught it. So when you have radicals, an entire radical, your teacher taught you that you can square the root the top, square root the bottom, right? So I did that on the top and I got 3/5. That's the previous question, yes? Now this one, if I square root it, 100 is 10 and 91 is root 91. Yes? So I can actually, whenever I'm doing that square root, I'm square rooting both numbers separately, correct? Technically? So I can write this as plus or minus the square root of 91 over what? Square root of 100, which is 10. Do you see that? How you can split it up? Because you're square rooting 91, and then you're square rooting 100, but the square root of 100 is 10. That's a nice one. And why am I writing 91? Anyone? Oh, I am writing 91 for a reason. 100 minus 9. Stop. Does that work? Can I split them? Yeah, I did in the previous one. I did square root of 9 is 3. Square root of 25 is 5. Here I did square root of 91. Square root of 91. Square root of 100 is 10. Yes? All right. So my two possible coordinates could be 3, 10 over root 91, 10. Or 3, 10, comma, negative root 91, 10. I need quadrant 4. Quadrant 4 is in the bottom right, so I need a positive x and a negative y, which means it's this one. We agree? You try C, D. This one we would have x squared plus 5/13 squared equals 1. X squared plus 25/169 equals 1. 169/169 minus 25/169. X squared equals 144/169. Square root it, get plus or minus. So x equals plus or minus 12/13. So we would have 12/13 and 5/13, or negative 12/13, 5/13. Which one's in quadrant 2? First or second? Second. Then this one. Unless it said algebraically, I wouldn't even have to show work. Yeah.
Why do we label the one that we don't use as extraneous?
Because you could put extraneous point or whatever, but most people, I'm just showing the 2 points. I normally don't even show the second one. But you can say that this is outside. It's not really extraneous, it's just not in quadrant 2. Yeah. Quadrant 3, we know that negative 1/2 goes with what every single time? Root 3/2, and I need to be in quadrant 3, so it would be negative root 3/2 and negative 1/2. This one says they want to know if the point is on the unit circle. On the unit circle, whenever I see that, I say x squared plus y squared equals 1. I have an x. I have a y. Do I just plug them in and see if it equals 1? Yeah. So A and B, go. This one, I get 0.65 squared plus negative 0.76 squared equals 1. What does this left-hand side equal? 1 decimal. Is that true? Are they equal? No. What's happening is this one has a radius of 1.001. So your radius of your unit circle is 1. This coordinate is just like literally right on the outside of that unit circle. But it's not on the unit circle. It's literally extremely close. You need a magnifying glass to see it, but it is not on the unit circle. So, because it doesn't have a radius of 1, it has a radius of 1.001. This one we already know is, but we have to prove it. Because it's root 2 over 2, technically, and negative root 2 over 2. This one we're going to get 1 over 2, because the root square root of 2 squared is 2. And then 1 over 2. And a half plus a half is 1. So in your homework from yesterday, you could only do 1 to 6. 7 we're doing later. Don't like scrape it off. We're going to do it, just not today. So 1 to 6. And then today's is the back side of that, 4.2. So you have the homework from yesterday today on one sheet of paper.
I